So at the beginning of this chapter, we're going to focus on exponents and their properties. But before we start talking about exponents, we do need to establish a couple of vocabulary words. So first is a monomial. So mono means one. It essentially means it's one term. Now, one term can mean just a number. It could mean just a variable, or the product of a number and one or more variables with non-negative exponents. So positive exponents are fine. It's okay if it's x squared or 3x squared, but you can't have negative variables. So another way to think about it is if you see addition, if you see subtraction, or a variable in the denominator, then it's not a monomial. Otherwise, it is. So some examples that are monomials, it could just be the number 4, it could just be a variable y, or it could be a combination of those things, even with exponents. So those are all monomials. Individually, they're monomials. But if I see 4 minus x, that's not, because we've got subtraction, so that's two different terms. Or if I have x plus z, that's not a monomial because we see addition, so that's two different terms. Or if I see 3 over x squared, that's not a monomial because if we rewrote that, it would have a negative exponent, 3x to the negative 2. So that's why variables in the denominator won't work. Now I do want to add one more to the yes pile, because a number can be in the denominator. I could say 2/5 x, because it's okay for a number to be in the denominator, just not a variable. So those are monomials. The other is a power. A power is an expression of the form x or any other variable raised to a number. So that n does represent a number. It's just saying it can be different numbers, and that's okay, but it's x raised to a number. So our rule we're going to start with is the product of powers. So what happens when we're multiplying x squared times x cubed, or y to the 5th times y to the 7th? So to multiply two powers that have the same base, you simply add the exponents. So if they have the same base and they're being multiplied together, it's that easy. You just add the exponents together. So number 1, I think that focus will be a little better. Just a second. They have the same base, so I just do 2 plus 5. The answer is x to the 7th. Number 2, they have the same base, so I just add 3 plus 2 and get m to the 5th. Okay, now number 3, remember there's an understood 1 when no exponent is written. So you've got to remember that, because x times x to the 4th means you have to add 1 plus 4 to get x to the 5th. Now in number 4, the x part is just as simple as we've been doing. So it'd be x, then 2 plus 6 is 8. But we also have to multiply the coefficients by each other. But it's important to recognize the coefficients, the 3 and the 4, they're not affected by those exponents. The exponents are only applying to the x. So I just do 3 times 4 is 12 and place that in front of that. Okay, so on number 5, I'm going to go ahead and do the coefficients first. 1/2 times 2 is 1. 1 times 4 is 4. Then I have the variables a cubed and a to the 1st. So don't forget there's a 1 that's understood when nothing's written. And 3 plus 1 is 4. Now in 6, we have multiple variables. Now this is a monomial. You can have more than one variable. This is a monomial. So the coefficient, the only one we have is a 4. It just stays as it is. And we can't combine the x's and the y's in this sense, but we can combine them individually. In other words, I can do x squared times x to the first and get x cubed, and do y to the first times y cubed and get y to the fourth. So if there's more than one variable in the term, you can still multiply them, just make sure you do each of them separately. I can't just say, well, 2 plus 1 plus 1 plus 3 is 7, so I just get xy to the 7th. You can't do that. We can only combine the x's and the y's. Okay, number 7, negative 4 times negative 5 is positive 20. And with m, we add 3 plus 7 and get 10. Number 8, negative 5 times 2 is negative 10. X to the fourth times x to the first is x to the fifth, because 4 plus 1 is 5. Number 9, negative 2 times 3 is negative 6. A cubed times a to the first, we do 3 plus 1 and get 4. B to the first times b to the fourth is b to the fifth, because 1 plus 4 is 5. Okay, now this is a different rule. When a monomial with an exponent is raised to another exponent, multiply the exponents. That doesn't need to be 2 spaces, sorry about that. Multiply. So I want to make sure you see the difference between these two. This rule, we had 2 bases. Now they're the same base, but I'm just saying there were 2 terms being multiplied together. There are 2 terms being multiplied together. Here, there's just 1 term, but it has 2 exponents. So when there's 2 exponents like this, instead of adding them together, you multiply them together. Or, if you have 2 different bases inside of parentheses, then the exponent on the outside applies to both of them. And really we're still multiplying, because that's x to the first and y to the first. So 1 times m is m, 1 times m is m. And I want to briefly try to show you why this works this way. Let's consider x squared times x cubed. Think about what the exponents really mean. X squared means x times x. X cubed means x times x times x. So if you look, we have 5 x's being combined, which we can shorthand into x to the fifth. So that's why you can just add these 2 exponents together and get the answer. However, if I have x squared cubed, well, x squared means x times x. And cubed means we multiply that thing by itself 3 times. So x times x once, x times x twice, x times x 3 times. If you look here, we have a total of 6 x's. So that's why this would be equal to x to the 6th. So we multiply 2 times 3 to get the answer here. So let's practice these. Number 1, we have x cubed being raised to the 5th. So we multiply 3 times 5 and get 15. A to the 5th squared, we do 5 times 2 and get 10. 3, m to the 4th raised to the 5th. 4 times 5 is 20. Okay, now number 4. When you look carefully, this cubed right here applies only to the x. However, this cubed out here applies to both the x cubed and the 2. So we have to apply this cubed to both the 2 and the x cubed. So this is really 2 to the first. So I would do 1 times 3 is 3, so 2 to the 3rd power. X to the 3rd cubed, or x cubed cubed, we do 3 times 3 and get 9. Now I will accept this answer, but especially since you have a calculator, I really want you to go ahead and evaluate 2 cubed. So you can type in your calculator 2 cubed and find out that's equal to 8. So I will accept this answer, but this is the better version of the answer. Okay, number 5, we've got to square both of these. So this is negative 5 squared and x squared. Okay, now if you keep the parentheses around it, this answer is correct. However, if you don't, this is wrong, because you're not just squaring the 5, you're squaring negative 5. And negative 5 times negative 5 is positive 25. So we get 25x squared. Okay, on number 6, we have to apply this to both things inside, just like this rule talked about. If there's an exponent outside and more than one variable inside, we apply it to both of them. So we have to do 2 times 3, get 8 to the 6th, 2 times 4, and get b cubed. Okay, on 7, I'd recommend we do a step in between, because notice this one is outside the parentheses, so you've got to apply this to the inside first. So 3 squared, x squared, and y squared, because it applies to all 3 of them. Then we'll multiply, that's a squared, negative 2x squared, y to the 4th. So 3 squared is 9. 9 times negative 2 is negative 18. X squared times x squared is x to the 4th. We're using the old rule there. We're adding them together. Y squared times y to the 4th is y to the 6th. So this one combines both the rules. We applied the new rule, the power of a power, in order to simplify this term, because the x put it outside the parentheses. But then to combine these two, we had to use the rule on the front of the page, where x squared, 2 plus 2 is 4. Y squared, y to the 4th, 2 plus 4 is 6. Number 8, we need to apply this 5 to both of these. 2 times 5 is 10. Y times 3 is 15. 3 times 5 is 15. So we get y to the 15th. Okay, number 9 is similar to number 7 in the sense that we need to go ahead and take care of this first. So do the power of a power first. Two times 3 is 6, we get b to the 6th. Then we have 2a cubed, but then b squared times b to the 6th, we add the exponents together and get b to the 8th. Okay, we'll do something similar on 10. We'll go ahead and simplify this one before we combine them. 3 squared is 9. X squared is x squared. Y cubed squared, we do 3 times 2 and get 6. So our coefficients are negative 4 times 9, which is negative 36. X squared times x squared, we add 2 and 2 and get 4. And then y to the 1st times y to the 6th gives us y to the 7th, because 1 plus 6 is 7. Okay, last one. Any monomial raised to a power of 0 equals 1. Anything, no matter how big or small the number, or if it's a variable, anything raised to the 0 power equals 1. So x to the 0 power, it's 1. 5 to the 0 power, it's 1. 3x squared times y, all raised to the 0 power, it's 1. So I bet you can guess number 23, right? Well, if you said 1, you're wrong, because this 0 applies only to the x. So we still have the 5, but then x to the 0 is equal to 1. So this one is equal to 5. So this is important to remember. Anything raised to the 0 power equals 1, but only what's being raised to the 0 power, which in this case is the x, becomes a 1. So make sure you know when the exponent applies and when it does not.